Hello guys, with National Quantum Mission launch, India entering race for advanced computing in big way. There are still computational tasks that even the most powerful computers can't handle. We must change the rules and build computing machines that follow the laws of QM. अभी भी बहुत सारे कंप्यूटेशनल टास्क है जो कि मोस्ट पावरफुल कंप्यूटर भी हैंडल नहीं कर सकता. इसलिए हम लोग को चेंज करना होगा रूल को, बिल्ड करना होगा कंप्यूटिंग मशीन्स को जो कि फॉलो करे लॉ क्वांटम मैकेनिक्स का. आप फोटो देख सकते हैं, ये है क्वांटम मैकेनिक्स का ब्रेन फिगर. The rapid advances in the computing technology since the second half of the 20th century have completely changed every aspect of our life. There seems to be no limit to the capabilities of a modern computer, but did you know that there are still several mathematical and computational tasks that even the most powerful computers available today can't handle? Even if they become much faster in the future, some problems will remain beyond the scope of computers based on the current classical technologies. रैपिड एडवांस हो रहा है कंप्यूटर 20th सेंचुरी में, और कंप्यूटर को देख के लगता है भाई ये आज का मतलब गॉड है. एक तरह से कंप्यूटर में सारी चीज़ें हो सकती हैं, लेकिन अभी भी कुछ चीज़ें ऐसी हैं जिनको कंप्यूटर नहीं हैंडल कर सकता. यदि कंप्यूटर की रफ्तार उसकी पूरी चीज़ को अपग्रेड किया जाए फ्यूचर की तरह, तो तब भी वो उस चीज़ को हैंडल नहीं कर सकता. वो चीज़ मैं आगे बताने वाला हूँ. दैट इज़ वेयर द क्वांटम मैकेनिक कंप्यूटर्स can show the way forward, and with the launch of the National Quantum Mission 2 weeks ago, India is pursuing this a big way. क्वांटम मैकेनिक्स, इसको कंप्यूटर अभी भी सॉल्व नहीं कर सकता, और क्वांटम कंप्यूटर की मदद से एक आगे की तरफ इंडिया अपनी दिशा को बना रहा है, जिसमें लॉन्च किया नेशनल क्वांटम मिशन 2 weeks ago. इंडिया जो है इसको परस्यू कर रहा है बड़े वे में. द एबीसी ऑफ अ क्वांटम कंप्यूटिंग, मल्टीप्लाइंग टू प्राइम नंबर ए एंड बी टू फाइंड द प्रोडक्ट्स इज अ ट्राइवल टास्क फॉर एनी कंप्यूटर, बट गिवन सी द रिवर्स प्रॉब्लम ऑफ फाइंडिंग ए एंड बी इज लॉट मोर कॉम्प्लिकेटेड, and this problem becomes impossible to solve once A and B become very large. The complexity of this problem forms the basis of how we protect sensitive data, like our credit card numbers, from being stolen when used for online transaction. Another important example is connected to quantum mechanics, the branch of physics that studies nature at the microscopic scale of atoms and electrons. मल्टीप्लाई करना दो नंबर से और बी को फाइंड करने के लिए सी, ये ट्राइवल टास्क है किसी भी कंप्यूटर के लिए, लेकिन जो सी है और रिवर्स प्रॉब्लम फाइंड करना ए और बी का, तो ये ज़्यादा कॉम्प्लिकेटेड हो जाएगा. ये जो प्रॉब्लम है इम्पॉसिबल सॉल्व करना, वो ए और बी जब लार्ज हो जाए, और जो कॉम्प्लेक्सिटी है इस प्रॉब्लम की, ये फॉर्म करती है बेसिस की कैसे हम लोग प्रोटेक्ट करें सेंसिटिव डाटा, जिसमें हमारा क्रेडिट कार्ड नंबर अगर चोरी हो जाए जब हम लोग यूज़ करें ऑनलाइन ट्रांजेक्शन के लिए. अनदर इंपॉर्टेंट एग्जाम्पल जो है कनेक्ट किया जाता है क्वांटम मैकेनिक्स में, द ब्रांच ऑफ फिजिक्स that studies the nature of microscopic scale of atoms and electrons. With the help of computer, we can easily solve quantum mechanics equation for hydrogen atom, which contains one proton and one electron, or a hydrogen molecule, which contains two hydrogen atom. But if we go to somewhat more complex molecule, say that of a medicine aspirin, which has 9 carbon atom, 8 hydrogen atom, and 4 oxygen atom, the quantum mechanics equation are impossible to solve even if we use the most powerful computer available today. अगर हम लोग कंप्यूटर यूज़ कर रहे हैं तो हम लोग इजीली सॉल्व कर सकते हैं क्वांटम मैकेनिक्स इक्वेशन हाइड्रोजन एटम के लिए, जो कि कंटेन करता है एक प्रोटॉन और एक इलेक्ट्रॉन, या हाइड्रोजन मॉलिक्यूल, और जो कि कंटेन करता है दो हाइड्रोजन एटम. लेकिन अब हम लोग ज़्यादा कॉम्प्लेक्स मॉलिक्यूल है, जैसे मेडिसिन एस्पिरिन ले, जो कि 9 कार्बन एटम, 8 हाइड्रोजन एटम, 4 ऑक्सीजन एटम कंटेन करता है. क्वांटम मैकेनिक्स इक्वेशन जो इम्पॉसिबल है सॉल्व करने के लिए, यदि आज का सबसे मोस्ट पावरफुल कंप्यूटर भी यूज़ किया जाए तो कैन वी एवर सॉल्व सच प्रॉब्लम्स दैट क्लियरली हैव सिग्निफिकेंट implication फॉर सोसाइटी एज अ होल? द आंसर इज yes. But we must change the rules and build the computing machines that follow the strange and counterintuitive laws of quantum mechanics for storing and processing the information. Such a machine is called a quantum computer, where the fundamental unit of information is called quantum bit or qubit. यदि इस तरह की समस्या को सॉल्व करने से उसके लिए क्वांटम कंप्यूटर आएगा या बनाया जाएगा, और इंडिया इसके लिए काम कर रहा है, जहाँ पे फंडामेंटल यूनिट जो इन्फॉर्मेशन का उसको क्वांटम बिट या क्यूबिट कहा जाएगा. Unlike classical bits in a conventional digits computers that can take the value 0 or 1, qubits can be prepared in an arbitrary combination of 0 and 1. Such a combination is called superposition state. As we go from one qubit to many, the number of such available quantum states grow rapidly. 2 states for 1 qubit, 4 states for 2 qubits, and 1024 states for 10 qubits. The number of such states in modest quantum computer with, say, 300 qubits become larger. Then the number of atoms in the entire visible universe, one can now create a superposition that is combination of all those states and manipulate it. The ability to create and manipulate such a large number of states is one of the key factors that make quantum computers extremely powerful compared to the conventional computers when solving certain kinds of problems. The power does not come from doing the task faster, but by doing it in a completely different way, a sort of quantum a shortcut. In the 1990s, Peter Short, a scientist working at Bell Labs, US, showed that if one uses these basic rules, yeah, new rules, they can actually solve the prime factorization problem explained earlier. Lee Grover also from the Bell Loop showed that the certain type of search problem can be solved with much fewer steps, and thus began the phrase to build quantum computer. The goal, the National Quantum Mission approved by Union Cabinet with a budget of 6,000 crore rupiah, will focus on several aspects of quantum technologies and is broadly divided into four verticals: quantum computing and simulation, quantum communication, quantum sensing and metrology, quantum material and devices. Each of these verticals will be coordinated by Thermatic Hub, which will be set up as a section and company to provide more freedom and flexibility compared to conventional funding models. All our relevant stakeholders are expected to come together to form a cohesive team to build the T hubs by an open call. In addition, the hubs will also carry out translational research, incubate startups, create links with the industries, foster international collaboration, run for outsearch program, and also develop a comprehensive human resource development initiative to create the workforce needed to execute this mission. There are several computing approaches to build a quantum computing hardware. Since it is not yet clear which method is likely to yield a practical quantum computer, the National Quantum Mission will focus on key hardware platforms such as trapped ion, superconducting, semiconducting, photoionic, and neutral atom qubits, while keeping a close eye on any new emerging platform. Goal is to develop quantum computer with 50 to 100 qubits in about 5 years and accelerate to 1000 qubits and beyond in 8 years across the several hardware platforms. Today's qubits are still unstable and only retain information for a short time of the order of millisecond or less. Hence, a strong emphasis will be given to the development of a methods to stabilize these qubits using quantum error correction and improve the accuracy of the computer. There will also be a focus on developing quantum software for the application relevant to India's needs. The mission will create an ecosystem that will enable startup to develop and provide component technology for quantum computer and also create second business cases in the long run. The challenges. While ample funding is important, it is the setting up of systems and processes that will be key to the National Quantum Mission's success. This will need include aggressive hiring of new talent, intensive training programs, and industry engagement to create future opportunities for the workforce, practices to attract and retain good talent by reducing delays in the disbursal of fund and eliminating restriction on the import of critical enabling technologies. We will be able to progress rapidly and prevent the wastage of time and resources. The mission will generate several indigenously developed technologies, but in an increasingly globalized world, a careful balance must be struck between a push for self-reliance and quick access to much needed global resources. While several breakthroughs are still need to be make the quantum computers practical and useful, the mission should aim to create the right condition for this advancement to take places in India. Quantum computing and other computing technologies are being aggressively pursued by many countries in the world. The National Quantum Mission offers a tremendous opportunity for India to contribute significantly in this area with many factors and conditions in its favor, such as large and young talent pool, rapidly accelerating infrastructure for high-tech R&D. However, it will require dedicated teamwork with a smart and efficient execution from all the stakeholders. As optical mix of basic, applied and translational R&D with a continuous effective evolution program are needed to keep India relevant in this highly critical area of science and technology and to set the stage for taking the leadership position in the 21st century. Professor R. Vijayakanna is an associate professor of physics at the Tata Institute of Fundamental Research, Mumbai, and is an expert on superconducting quantum processor. Views are personal. So guys, tab tak le goodbye, tata, bye bye.